Hey everyone, so welcome to our latest Share Friday where we've got a special guest, Crypto Wanderer, who has promised to read us some poetry at some point during the session. And we're going to be talking about mechanism design, token models, all of that. I won't speak too much more, just that Andy has a great philosophy on life and is super interesting. So take it away, Andy.
Yeah, that's quite a big intro to live up to. But thanks so much for having me. It's great to see the team. I'm kind of disappointed. Okay, let me just make sure that we're looking at the right kind of screen. I must admit that I'm kind of disappointed to see that Denim still has hair. I was, gonna nominate him for best hair in Ethereum in a celebrity deathmatch with James Prestwich. And he told me that he shaved it. He shaved it all off for cancer, but I see that's a relative. Yeah. Anyway, what I am going to talk about today is my particular work with token design and a very simple and straightforward mechanism for this site, which is dop.ps, and is using SNT, a particular token, the status network token, to curate and rank dApps in a provably fair way. And I thought that's what I would do is take us through the actual means by which I came up with this mechanism and the mechanics of designing a mechanism, if I can put it like that, because it's often non-obvious to people. And in particular, I sort of very strongly recommend this beautiful essay by a guy called Brett Victor, which is called The Ladder of Abstraction. And what Brett is talking about here is designing a simple algorithm for a self-driving car to turn around a corner, and the various different layers or levels of abstraction at which you have to consider the problem if you want to come up with a legitimate solution. This has to do not just with the kind of angle of incidence and how you get around a curve, but also controlling time and seeing what happens with various different trajectories across time, and then looking at moving the algorithm around and abstracting over time and all of these interesting things. And the reason that this particular essay is interesting in the context of mechanism design and tokens is that there are also various different levels of abstraction you have to think about. The first is obviously your design goals and what you actually want the system to achieve. So in the context of dApps, what I want to achieve is that the people who rank highest in the system provide the most value to the community. That's a very good and succinct high-level goal, but it's fuzzy, right? Inherently so, because how is it that we actually define value? In current systems across Web 2, whether we're talking about Amazon's algorithm or PageRank or any kind of social news feed, we see that the way in which value is defined is generally speaking to do with likes or retweets or number of views or user ratings and reviews. And all of these things are inherently gameable, and they're certainly open to something called Sybil attacks, which is where I can spoof a whole bunch of different identities and make fake ratings or fake views or fake likes. And so having this high-level goal of whoever ranks highest provides the most value to the community is great, but I need to be able to think about what that actually means at various different levels of abstraction and be able to abstract over all of them in order to come up with a legitimately useful mechanic that will actually help me achieve my design goal. So how do we do that? This is kind of the ultimate question in many ways. And my particular solution here is a very, very simple game mechanic that, before I kind of dive into the maths and demonstrate these various different layers that I traveled through to come up with this particular algorithm, I know that providing the most value, and the simplest possible game mechanic that I can come up with that actually achieves this in an economic sense is to say, well, whoever stakes the most tokens, as you can see here, ranks highest, with the caveat that the more tokens you stake, the cheaper it is to downvote you, right? This is really important because it means that we can ensure that whoever is literally locking the most value out of circulation and therefore providing the most economic value to the community in an objective and measurable way is ranking highest, while also protecting against, simply making sure that the people who have the most resources rank highest, right? That there is a fine balance to be struck between, it's clear that these people who are ranking the highest are providing the most value, but we also want to ensure that people who are just, very, very well resourced can't automatically game the system and win, because the more resources that you stake, the cheaper it's going to be to downvote you. So I have my mechanic, right? I know that I have this high-level goal. I want to make sure that people who rank highly provide the most value. I know how I'm going to do that by saying that the more you stake, the higher you rank, but the cheaper it is to downvote you. How now do I actually design this mechanism, right? And it's certainly not by immediately going into my text editor and trying to write Solidity that expresses this high-level mechanic. I need to actually think about the maths, right? I'll share this spreadsheet with you if you like. I've also sort of shared it in the kernel Slack, which this week happens to be about tokens and mechanism design, and we can talk about some of the wider ideas once I've presented this particular work. But you can see that, like, I spent, a really long time in an Excel spreadsheet just kind of going through various different ways of designing this algorithm to get the desired curve that I eventually ended up implementing. And I'm not going to talk through all of this stuff, but there was like a lot of different attempts on my parts where I'm trying to figure out, man, how do I take all of these different variables that are at play in any given ranking system and express them in terms of each other so that I can come up eventually, hopefully, with just one variable that is like the critical one that I can change in order to understand the economics and overall behavior of the system. If you look at, like, over here, all of these green fields are things that I can potentially change and have to reason about, and there are different parameters that have different effects on the actual numbers in the system. And that's not good enough, right? I need, if I'm going to have this very simple system which ensures my high-level design goals, I need to be able to reason about it directly. And in order to do that, I need to try and limit the amount of parameters that I'm working with in my token design in order to, as I say, reason about it coherently. And there's something deep at play here, because if we're working with cryptocurrencies, in this case SNT, any kind of token is, especially in these early days of these cryptocurrencies and new economic networks, the value relative to other values that people understand and use in the world, like US dollars, is inherently volatile, which in and of itself is very difficult to model. So if you're building a token economy using a token whose value is volatile relative to what people actually use in the world, and then you have multiple different parameters, all of which affect the mechanism that you're designing with that token, it becomes impossible to model the actual effects of these things. So I knew that I wanted to use something like a token curated registry, except I also knew that the notion of, a bonded curve or a TCR, it uses two tokens, right? You have the token that you stake or that you deposit into the curve, and then something that you mint as a result of that, right? And often the thinking is that, cool, we're going to get people to stake tokens, and then we'll mint more tokens that we hand out to the community to incentivize the community to do curation for us. And that makes the system decentralized, which is really bullshit when you think about it, because the whole point of building decentralized systems is to build systems without a single point of failure. If you're relying on the community to make your system work, then the community is itself a central point of failure. Moreover, if you have two tokens, it seems highly contrived, right? Like when I use Google, I don't want to have to manage multiple different tokens in a wallet that then dictates using different on-chain governance rules and require all sorts of attention and focus from me. Just to like order the search that I make in any Google search, right? Like I just want to know that the things which appear at the highest positions are those which are providing the most value to the communities of which I'm a part of and are most beneficial to me. And so in fact, we don't need two tokens, right? Like I am using a bonded curve here, but the votes that you're minting, right? You're staking SNT as you would in any kind of bonded curve, but the votes that you're minting are not tokens in the traditional sense of the word, right? They're just key value mappings in a contract. This is sort of beginning to illustrate what I mean by many different layers of abstraction, right? Because I'm now using what I know about writing Solidity to actually understand how I can model the maths here in a way which will make overall sense in the system, right? And I can understand that, in fact, these votes that I'm minting, I'm never going to give them to people. I'm never going to require people to look in their wallets to understand how many votes they have, anything like that. The votes are simply a key value mapping in the contracts that are minted depending on how much SNT is staked for each DApp. The more SNT you stake, the more votes are minted, relatively speaking. And this means, because there is a cap on the cost of the total votes for any DApp, that the more you stake, the cheaper it is to buy votes, which is the exact mechanic that I require in order to make sure that the more you stake, the cheaper it is in general to downvote you. Right? It becomes more complicated than that, of course. Like I was exploring many different ways of trying to like do this, as you can see, sort of earlier on. But in addition to the recognition that, in fact, you don't require a complicated bonded curve, you can simplify it so that you're only using one token, which you can reason about coherently. I sort of realized that, like as you're staking more, yes, it should be cheaper to downvote you, but that's relative, right? Because if I stake 100 tokens, one token downvote makes a big impact. If I stake 1 million tokens, that same one token doesn't make as quite big an impact. So in fact, what this curve is modeling is the percent effect that any negative votes will have on your overall standing in the rankings. And this is why we get this very, very interesting cost curve, which, as you can see, because I've been able to use the maths to actually relate all of these different variables, the rate at which votes are minted based on how much SNT is staked, the amount of SNT staked that is available to mint votes with, the effective balance we use to calculate what the votes, like how many votes it will take to move you down by the specified percentage, and therefore the cost to down votes. These are all mathematically related to each other, such that I can generate this really, really interesting cost curve that actually gives me what I really require for my high-level design goal, which, again, just to repeat, to emphasize it, is that whoever ranks highest is providing the most value to the community. But the more value you provide, the easier it is for the community to influence your position in their rankings. And I've been able now, through like various different explorations in the spreadsheets, to relate all of my variables to one particular and most relevant variable, which I can then tweak to try and understand what the effect on the system is actually going to be from an economic perspective, right? And it's this percentage ceiling, which is really like all it's saying is there is a set number of SNT in circulation. What is the percentage of that which a DApp could conceivably stake? What is the most SNT that a DApp can stake in the system before it becomes essentially costless to downvote them, right? And this is something that I can reason about economically, even though it's hard because the value in US dollar terms of SNT goes up and down. So it's not a simple thing to model. I can actually think about, how much conceivably would somebody be willing to spend to rank in this system? And if it's over, for instance, like $1 million, then it should be essentially costless for people to downvote them. And so, I can reason coherently in a very precise economic way about this single variable, which, if I change it, even it's, I'm not logged in. No. That's silly.
While you log in, maybe we can go through some questions. I think very good high-level description. I wonder if people might be interested to just go through slowly some of the values on the graph.
Sure.
If you could do that, it would be helpful. And then we've got quite a few questions to come in.
Okay. So I wonder, are there particular questions about which values on the graph I should start with, or
do you mind if I ask a question rather about the high level thing first before
Please.
The numbers?
Please.
With the voting, like how does the voting work if there are no tokens? So me as a person who wants to vote downvote or upvote someone on the in the community, how does the system know that there is a vote? Do you know what I mean? Also, just keep in mind, I don't know too much about the whole Ethereum thing, so maybe this is a noob question, but yeah, keep that in mind.
No, it's a great question, and it's non-obvious, particularly from the way that I've presented it here. Because these votes are just values, mapping in a contract, you never actually touch them, right? There is what the votes are being used to achieve, right? This red curve, which goes off to infinity, is the votes minted, right? And you never actually touch them as a user. What the votes are being used to achieve is this blue cost curve, which is to say that it costs you as a user to vote, either to upvote or downvote. And this is a radical departure from what token curated registries generally do, right? As I said, the general thinking with token curated registries is we'll stake a token, we'll mint a token based off that, and we'll use this minted token to incentivize the community to do curation. And that's how we should do things. And my contention is that this is bullshit for two reasons. First of all, it's not decentralized because then the community itself becomes a single point of failure. And if they don't interact with your system, then it doesn't work. And this is compounded by the fact that if we look at any DAO or TCR, people don't interact with your system. It's really, really difficult to reach Quora in these kinds of systems. And it's not because humans suck or any of these kind of things. It's because the amount of attention required to actually coherently be involved in these kinds of systems often exceeds our ability to, our mental overheads. So what people are trying to do is they're saying, by minting these tokens, we're going to incentivize away this fundamental fact of human attention and our fundamental human nature to be kind of stingy with it. Whereas what I'm saying in this is hey, there is a limit on human attention. People don't necessarily participate in these kinds of systems in the ways that you would want them to. We've seen that with the DAO. We've seen that with every single TCR that has ever been made. So let's design an incentive system which works around that. What the result of that is, in technical terms, is that it costs you to vote in the system. If I want to vote on, I'm also not logged into MetaMask in this window, but if I want to upvote or downvote, there is a cost in S&T that I have to pay, right? And that's...
And a rather painful gas cost too at the moment.
Yes, with a painful gas cost at the moment, of course. I'm a little bit less concerned about that at the moment than perhaps some people in kernel are, because I see this as a long-term thing, and we'll get onto ETH too. And these systems don't require a lot of interaction to work, right? So it doesn't matter if you wait a few days to vote currently. But of course, we can speak about.
Sorry to interrupt. Could you speak about incentives for people to interact? So, why would I want to downvote or upvote? Is that all? Yeah, you've obviously thought about that a lot, so I think that would be interesting.
Yeah, and Jason, the answer here is very, very simple. There are none. And again, like that, it comes across as really strange to people because all of the theory around bonded curves and TCRs to date has been about, you have to incentivize people to like take certain actions. No, that's wrong, right? Like when I do a Google search, I don't care about how it is that how PageRank actually works at a mechanistic level, and I don't want to be involved in that algorithm. I just want to be assured of its results. The problem, of course, is that in order to be assured of its results, I have to trust Google not to be evil. Whereas what this system is showing you is that like we can't be evil. Here's the proof, and the proof is in the economic pudding. Like if then, as a user, I feel very, very strongly about a given thing, say for instance, delete Facebook starts trending again, then as a user, and as opposed to current systems like Google search and these things, I can have an influence on the rankings, but it costs me to do that, which seems right. Like that if I want to like have my voice heard, there is an economic cost to that being the case, right? So I can't just sort of like troll and social media say, oh, delete Facebook, and then there's no economic effect to that kind of thing. It's like if I have an intrinsic motivation as a user to dislike or to fund a given product, then I can do that, but it costs, right? And so there's the incentives are literally 180 degrees to how you would normally think of a bonded curve in a TCR, and it's because like A, I know some psychology and I know some stuff about human attention, and B, if you just look at the history of DAOs and TCRs, they don't work in the ways that the creators intend them to, because you're literally trying to incentivize away a fundamental fact about human nature and attention rather than designing an incentive system around it. And that's always seemed like a strange thing to me. And so people already struggle with this concept. Oh, like how does it, how are you ever going to build systems in which it costs users to like vote? Well, put your money where your mouth is a long cliche from a long time ago, and it's important in these kind of like social ranking systems. And the other point to make about it, which was made really in like kernel, this let me go to it. Made in kernel this week, is that when you're doing virtuous design, there are these 8 kind of principles, richness and completeness, which I've kind of tried to expose through like talking about like how kind of complete my exploration of this particular space was, and it's the sort of surprise that I came through, and understanding that in fact like this kind of bonded serve, which only uses 1 token and the votes are just a key value mapping that are never actually touched by users, is much less contrived. What I'm really interested in, is this generosity point, which is to say that like when you're designing these mechanisms, when you're designing around tokens, scarcity is not a fundamental limit of the world. It is a design choice. And so in fact, like you can be incredibly generous with these kind of tokens, right? Like it's not necessarily shown in dApps exactly because SNT is traded on open markets and has a value associated with it. So there is a very specific cost that you can measure in US dollar terms. But when you're designing, token economics, these kind of things, if you're building like a social network, for instance, your token doesn't have to be traded on the open market. It doesn't have to have a USD value for it to be interesting and for it to have psychological effects in terms of how people interact with, use, and benefit from your system. It's sort of slightly deeper points, but this notion of generosity and token design and the way that it's combines with how we build pro-social value, in particular, sort of through player-to-player trust, player-to-player trade, and these positive sum knowledge resources are really interesting. I kind of want to focus more on the mechanism in this talk, if that's okay. But that's the sort of background philosophical take on incentives.
Perfect. That makes a lot of sense. I don't know if maybe we want to stop for a quick question from someone else.
Cool.
Okay, let's move on. Dana?
I have a few questions. I posted them in the comments if you don't mind pulling them up, or one of them. Jason, do you mind pulling it up?
There's like 5 questions. I'm waiting for you to say it before I
So
put it up.
the first one, I need to see what I need to check back to what I said I posted a while ago. Okay, cool. So maybe this one makes more sense a bit further down the line. But anyway, Andy, so this is quite an interesting model that you've, I think, come up with yourself. And when you were kind of designing this token curation registry, what other kind of voting mechanisms were you looking at? What kind of brought some motivation to this model? For me, kind of quadratic voting comes to mind. It's quite hot right now, but naturally kind of weak to Sybil attacks and the likes.
Yeah, it's a good question. I love the peacock in the background as well. It's super cool.
I've got a peacock and a baboon both sitting outside.
Amazing, man. This is Africa. Hey, what a thing. So, what can I say about this? I've been involved with maker governance for a long time. So a lot of the work that they have done, I've been a sort of peripherally on the side of and have watched closely. I've looked, very closely at quadratic voting and liberal radicalism and capital constrained liberal radicalism in particular. All of the work that Gitcoin has done around that. All of these things are interesting, right? But I would say that my, particular principle in this work was it has to be as simple as possible, right? I want a system which anybody, even if they've never seen a blockchain, can understand and benefit from, right? And that was really like the driving motivation in all of this work. It started off, you can see like really complex stuff. There's a lot of things going on here. You've got to change a lot of stuff, and there's all these notes. And like I went through all of these iterations because my driving goal in all of it is simplicity, right? It has to just be like upvotes and downvotes. And yes, there can be a lot of like mathematical complexity, but behind how those upvotes and downvotes are costed and what actually happens with the value flow in terms of like the contract. But it needs always to be presentable at a social level in the UI in the simplest possible manner. And, man, there are there are so many, if you just go and look at like the maker governance portal and all the work that's happening there now, there are so many different ways of doing voting, one person, one vote, first past the poll, ranked choice, various different victory kind of auctions, quadratic funding, the choices are endless, right? And eventually, after understanding like a lot of the theory behind all of these different voting algorithms, I was like, man, there's something unique about these new token economies that are based on a ledger of distributed trust, where I can actually map value flows in really interesting and clear and accountable manner. And that allows me to think slightly differently about, like what votes actually are ontologically, because here, they're just they're a key value mapping in a contract, ontologically speaking. And then use those votes. The reason that I kind of point to this pro-social thing is that, like, if you go to voting resources, what they're saying here is that votes are positive some economic resources. So if you model them as an economic resource, you can use all the tools of economics to think about interesting ways of doing voting, which have not been thought about before, right? And that's really what's at the heart of this. It's modeling votes as economic resources in a positive sum manner. You can see I've been generous with them to the extent that they go off to infinity, and I actually have problems in the contract handling that, which we can sort of get to. But this is the fundamental insight of this kind of work, right? If you want to speak about it at like a high conceptual level, is that votes here are just positive sum economic resources, and I'm using economic tools to model them, and then I'm using a universe of distributed trust in which I can take that model and implement the value flows implied by it in a decentralized ownership and ownerless and accountable fashion. Does that make sense?
Yeah, that was great. Thanks.
Cool. So yeah, unless there are sort of specific questions around like the exact values here, and I don't really kind of want to get into like the low level maths about like how these things are really decided upon, but I can if you really want to.
Could I try paraphrase? And I'm sure I'm wrong, but you can sort of correct me. Maybe that'll be interesting. Or on the mechanism. So basically, as people there's two buttons. There's vote up and vote down, and you choose how much to vote up with or how much to vote down with. The amount that your vote affects the ranking or the sort of positioning of that entity on that list, on how it's curated, depends on those curves. And if there's a lot voted for, at some point voting down has a stronger force on that vote than if very little is voted on that project. Something like that.
Yes,
and
exactly
those
right.
tokens are gone forever after I've voted. It's not like I can withdraw a vote. How does that work long term?
Yeah, it's really great questions, and this gets into sort of, now that we've done the maths, right? We can begin thinking about what it actually looks like in code, and understanding the maths and how it fits into the high level design goal. We now think about the value flows in the contracts, right? And what's actually happening when we're sending tokens to different places. So, Jason, as you can see, the critical feature of this is that it's the cost curve is mapped not on actual raw cost, but the percent effect that your votes have if they're down votes, right? That's really what we're interested in here. And it's because it makes the maths much simpler, and it's because doing maths in Solidity, particularly exponential maths, is very, very difficult. So when you downvote, so you see here Dragonarium, and this is the live production sites, right? This is on mainnet. Dragonarium has a balance of 60,695. So downvoting them, this is not an input field, right? I'm limited to downvoting by 1% always. And that's just, it's got to do with, as I say, problems with implementing exponential maths in Solidity and how difficult it can actually be and how costly from a gas perspective it is. So this is a trade-off made at the technical protocol level. It's not implied in the maths, but Solidity is limited. So you can see that downvoting them by 1%, even though their balance is 60,600, downvoting them by 1% costs less than 600 SNT. Whereas if I was to pick somebody with a low balance, let's say wildcards, because why not? You'll see that your balance is 2,181. Downvoting you by 1% costs 21 SNT, which is basically 1% of what it's. So the more and more that you stake, the more that disparity will become obvious, where downvoting you by 1% becomes significantly cheaper than 1% of your balance. Using 1% was an arbitrary choice that I eventually had to make in Solidity as a result of the maths limitations there. Doing exponents in Solidity is a mess. I've used the Bancor library, which is, huge love to the guys at Bancor. It's incredible. But in terms of this specific design, there are limitations, and those limitations are mostly defined by, just gas costs of endlessly looping through these increasingly large exponentials. So, yeah.
Just to fully understand, sorry, before you continue, the amount of S&T locked up for a project just grows. It never releases S&T.
So, you can withdraw if you no longer want to participate in this. You can withdraw. You cannot ever withdraw. If I try and load this, you can't withdraw the full amount. Right, you can withdraw 99% of it. What you can withdraw is the amount available. The rest, so if you stake 10,000, right, the amount available to vote with is 9,949. So you would have to leave that 51 S&T locked forever. Again, this has to do with limitations in the maths for the contract itself. So you can withdraw the vast amount of what you stake, but not all of it. And the more that you stake, say you stake 1.5 million, you'll see that in fact the amount available that you could withdraw is significantly lower than that. And this has to do, it's another feature of like how we actually ensure that we get to our high level mechanic, which is that the people who stake the most provide the most value to the community. So if you stake more and more and more, you can always withdraw, but the percentage of what you can withdraw gets lower and lower the more you stake, so that eventually you can see if this thing ever loads, it can be a little bit slow. But these are the like analytics on the contract itself in production. And you can see that we'll have like the total balance of the contracts, and then there should be it should be somewhere. We'll see if it ever, as I say, if it ever loads. There should be a locked amount. You can see that my Wild Coast internet is struggling a little bit. But does that make sense, at least conceptually? You can see, so there's like 305,000 S&T in the contract at the moment. 152,000 of that was staked. 163,000 has been donated through upvotes, and available to be withdrawn is 300,000. So that means that what is locked is forever in this contract is 4,451 so far. And again, that has this pro-social benefits of, like the more popular the system becomes, the more S&T will be permanently locked outside of circulation, decreasing demand. Decreasing supply, therefore driving up the price, at least in theory. Does that answer your question?
Totally, thanks.
No problem. Yeah. And it's just, all of these interesting mechanics, like this withdrawal thing, which is really fascinating when you think about it from a game theoretic perspective, come from that one high-level design goal. Whoever stakes the most needs to provide the most value. We achieve it by saying that if you provide more value, it's cheaper for the community to downvote you. And all of this, the rest of the stuff falls out of that. Now that I've kind of explored, I haven't been through the maths exactly, but we sort of say that the rate is defined by how much is staked, the ceiling that we've defined, which is this variable that we're going to play with, the actual, the ceiling as it applies to how much is actually in circulation. The amount available is just the S&T staked times the rate, and then the votes are the that amount available to the exponent, right? To the exponent of 1 over the rate. And this is how I've managed to relate all of the different variables to one thing, which is the ceiling. And now that I know that, I can actually go into, this is a really cool observable notebook where you can actually sort of write JavaScript. I wonder if this is not a good, sure, you can see. So you can actually write JavaScript here in the notebook and then have it render, for instance, like a graph, but any kind of thing. So then I went and actually began messing around with what's going on here. And I can see that, if I change my ceiling, this is the parameter which affects most drastically the shape of the curve and what's going on with different economic inputs, right? So I ended up choosing 2.92 because if you look, there are two considerations around this. It's got to do with at what point what's the inflection point of this blue curve, i.e. at how much S&T staked does it start getting significantly cheaper to downvote you than how much, as opposed, compared to how much you're adding, because after that particular point, there's no real incentive to sort of stake S&T. So, I think that not many more people will ever want to stake more than kind of 1 million S&T, but that's kind of a guess on my part. So the only aspect of the contract itself based on this that is actually changeable, because there's no owner on this contract. There's no special privileges. There's nothing. The only privilege, the only privileged route in this entire thing is set ceiling, right? There's only one only control a root in the whole contract. And that was also important from a design perspective, because like this sealing, I can see, yes, like there's an inflection point around 1 million S&T, which is what I'm guessing is the most that anybody will ever want to stake. And also I can see that there is a local minima in the number of votes minted. Like if I change this even just one, you can see it goes up to 211 or 227, all sorts of crazy numbers. Even the other side, 226, but at 2.92, there is this weird minima, which I thought was interesting mathematically. I'm not exactly sure how relevant it is, but it just seemed like it was a cool thing. Come on. A cool minima in the votes minted, and a nice sort of inflection point around 1 million S&T is what sort of got me to think, okay, 2.92 is the correct ceiling. But of course, like even that is very complex to model, and so this particular function is included in the contract, which will allow us to change the ceiling if the value of S&T moons or other unexpected and black swan-like events happen. The cool thing about these kind of notebooks is, in addition to kind of going through, let me see, there is another one that I was wanting to show you, because this particular notebook comes first. Just to show you how powerful these kind of notebooks can be. I'm sort of talking about the various different models, and then here you'll see the same curve, but I'm actually writing JavaScript to come up with these dynamically in the notebook. So if it's minted, I want this probably no cost. Yeah, so it gets sort of increasingly complicated the further down I go. And what I kind of really, I suppose, wanted to show you is all of the, I've now written the maths in the spreadsheet, understood my high-level mechanism, understood how I'm going to get there, understood the maths that it's going to take, and now I'm kind of translating it into code. And in particular, like JavaScript code, because it's quite close to Solidity, and that allows me to kind of map the stuff, see the graph, begin to start playing with it in an interesting fashion. And once I've, written the code and see that, hey, this stuff, like all of these equations which I've written in the spreadsheet are actually possible to implement in JavaScript, that means I can probably implement them in Solidity. Now I need to, before I go and write the contract, actually think about what the economic impact of this is going to be, right? And this gets really speculative, so I'm just going to kind of breeze through it. What I really want to kind of show you is how important these observable notebooks can be, because what I've done is, like, all of the econometric formulas, which I'm going to breeze through here, come from Barry, who is another smart contract developer at Status, and he built a whole bunch of notebooks that have to do with, calculating the probability of failure and the cost of equity and what S&T will close at and the cost of capital and all of these things, which I've just been able to import from him, so that having understood the overall mechanism, I can now try and, at least to a first approximation, model the economic impact of these kind of things. So if I look at the number of dApps in existence, the percentage of those that are mobile and useful, how many are going to be staking per year, how many are going to be withdrawing per year, I can look at, like, how many dApps are going to be in the store over the next 10 years, probably around 800, it seems to suggest, given like these assumptions. And this is, the problem with economics is that it's all assumptions, right? I don't actually know what these kind of churn and growth rates are going to be, but these seem to me like reasonable things, and I can play around with them and sort of see the effect of compounding growth. Even if I assume 1% rather than 0.3, it jumps from 800s at 1% growth. I'm then looking at like 39,000 different dApps, and that makes a very big impact later on when I'm trying to sort of understand what the actual economic, the aggregate dollar demand per year. All of the stuff is open source, and it's literally as easy as importing Barry's work. So like super easy to model. I didn't do any of this myself. The probability of failure based on a whole bunch of different milestones or qualifiers or mechanics. You can all sort of see them. I don't necessarily have to talk through all of them. There's different econometric models that we can talk about. I chose token bonding. It's to be honest, like the actual thing itself is highly decentralized, but I chose somewhat decentralized because the front end is still only being served from one place. You sort of put in a probability of failure and a discount rates. Then again, I look at kind of user growth and churn per annum. And here you begin to see, like, if you're actually like modeling the economics and looking after your systems and thinking about them long term, the first few years nothing much happens, right? Like $2,400 in the first year. This thing has been running less than a year. It's got 300,000 S&T in it, so like not quite $2,000, but if the value of S&T goes up, that changes very, very quickly. But in year 10, if it carries on to grow at this kind of rates, the effect is quite stark. This particular model is saying 43 million. And I dropped this in the Slack the other day, sort of kind of hoping that people would challenge me on it, because this particular econometric model that Barry is using is MV equals PQ, which is a macroeconomic equation that says, your monetary base times the velocity of money in that economy equals the price of goods times the quantity of them. And I'm not exactly sure that it's, directly relevant to this, because, these assumptions that I've made sort of suggest a net present utility value of $150 million, which I think is crazy. But, it's interesting, I think, to see the extent from which you can go from like a high level design goal to the maths, to making sure that the maths can actually be expressed and written in something like JavaScript, to then modeling the potential economic impact that this will have given various different assumptions. Until finally you then end up like actually building, a front end, hopefully hosted on IPFS or something like this, which can be replicated by many different people, and which, implements in a very tangible and realizable way the overall design goal, which is hopefully what we've got to. And, the last thing that I will say is we actually sort of need to be able to express not just the maths of this stuff, but the value flow, right? The flow of value through the contract itself. Because the last and most interesting piece of game theory caught up in all of this is that when I'm downvoting you, yes, it costs me. Where does that cost go? Well, for downvotes, it goes directly back to the developer who staked. For upvotes, you can see that this is an input field and I can put in whatever I want here. And this, like an upvote, just locks more S&T in the contract and assigns it to your balance. And these also result in very, very interesting game theoretic equilibria, right? Because if I want to compete with you and downvote you or just troll you, that's fine. I can do so and I can have an effect on your rating. But it costs me to do that, and that cost goes directly back to you, which is a really fascinating, I think, value flow, right? That's is not necessarily immediately obvious from the maths. Where is this cost actually going to go? Well, the cost for upvotes is just a direct contribution to your balance, which you can, remember, withdraw at any time. But downvotes, because we're actually talking about costs here, downvotes. Actually, you can see here's the upvotes, and it's just adding tokens to your balance. It's sort of calculating that and then adding the tokens to your effective balance. The downvotes are transferring it from you to the owner of the developer, and you can implement these very, very, very interesting value flows if you have a very clear high-level goal, a very clear mechanic for how you're going to achieve that. And then, like, as I say, all of this stuff just falls out as, richness and completeness and surprise in the actual code itself. And, that leads to what I would say, right, is and I know it's a really big claim, but, this is the optimal way to curate any piece of information in a decentralized context. So that's that.
Thanks, Andy.
Great,
This is
Andy.
fascinating.
That's fascinating. Yeah. I guess maybe we don't have a lot of time left. I'd like to find a way to sort of ground a lot of this theory into maybe some practical use cases you have. Like, for example, with wildcards, maybe we've got a whole lot of organizations now. We've got 20 organizations signed up. Would there be benefits in using this to curate the organizations, help people discover organizations on different criteria? I don't know, maybe you've got some ideas on where you want this work to go, and what improvements would you make if you were to redeploy it, for example? How would you change it?
Great question. Yeah. So, I mean, the other sort of feature of having a very simple goal is that it results in general solutions, right? So this contract can be used for any curation using any token, right? It currently has a mini-me because SNT is a mini-me token, but it doesn't require a mini-me token. It could be for any ERC20 token, as long as you are willing to set a ceiling, it helps to have a token with a set issuance with a set amount. So there's 6.8 billion SNT in circulation, and that is it. So that kind of helps. But you could, just arbitrarily set your own ceiling, even with a token like DAI, which, fluctuates in terms of its amounts. But you could say, look, we'll only ever use 50 million DAI to curate whatever we want to in our system. It's possible to make a good narrative argument for how you set your ceiling. So this contract is general, and it's generalizable. It can be used, as I say, for any token, for any, it's being used here to curate DApps, but the point is that it can be used to curate any piece of information which a given community is interesting, and it will curate that information in a way which is beneficial to the entire community of token holders, right? That was the big design goal. What I would say in terms of how it can be improved, which is a really great question, and how it can be improved is this line here. I thought a long time about how to improve this, and there probably are ways of doing it, and I'm not a good enough developer to come up with them. But the exponents, right, that you see here in terms of deciding on votes minted based on the rates and the amounts available, the exponents is implemented in the Bancor formula, which is really, really amazing. But it's as the maths kind of shows, it's actually easier to see here. The votes minted get very, very large. Especially once you've passed this inflection point, they get really, really ridiculously big. And so even the Bancor formula, which, as I've said, is genuinely amazing and is without a doubt the best exponent library out there. If I go to Bancor formula contracts, the best exponent library out there. We did a lot of different explorations, and Bancor is without a doubt the best. You can see how detailed this thing is, and they have an incredible test suite. But despite that, unfortunately, there is this feature in Discover that we can't actually quite get to the ceiling because it overflows at some point, and so there is, at 77% of the ceiling is where it overflowed, and I sort of spent many weeks trying to figure out where exactly that was, and it just seems that I'm not sure that there's anything unique about 77%. Just that at 78%, the votes minted overflowed and the contract failed. So this is something which there might be a way of improving the accuracy of the exponents, but it requires, understanding what that Bancor contract is doing, which is hex encoding various different, exponent values. And, that's, as they say in Afrikaans, boer my vuur plak. It's really above my pay grade. So perhaps somebody else can have a think about that.
Cool, Andy. Super interesting. I have another question, and it comes around to kind of the financial aspects of the token. So I would say it seems to be a bit of a trend at the moment that you have these governance tokens, which from my understanding are essentially a token used to vote on ideas around a project or something along the lines of that. And specifically this recent Wi-Fi or EFI token by Andre Grenier, he explicitly stated that he didn't want it to have a financial value. And yet soon after its launch, the value of the token kind of skyrocketed. And so 2 parts to this question. One, how would you kind of prevent financial value attached to a token? Would you make it something other than the ERC20 token? Or, yeah, thanks, Jason. And kind of what are your thoughts around these unintended financial values to these tokens?
It's an interesting question. I think that technically the answer is simple, which is to say, yes, you wouldn't use a standard, right? Because all of the places where you can exchange, i.e. establish any kind of value for any kind of token, require standard interfaces. So at a technical level, you can easily route around giving your token any kind of value by simply using a non-standard interface. And that indicates, does it not, that despite Andre saying in natural language, I don't want the value to be around this token, that his intention was not actually that, because it's very easy to implement a valueless token at a technical, in terms of the technicalities around it. So although, that's the narrative that he tells, the reality does not reflect it, because the actual code which executes these kind of things does not reflect it, because it uses a standard interface, which means that it can be traded, which means that it will inevitably have financial value. And it's not to say that it's disingenuous of him. He needed to say that for various kind of legal, regulatory, and other exposures to sort of have what we would call plausible deniability. Although if there was ever a judge that could write and read solidity, which I think we're safe on, it would be as obvious to them as it is to me that particular tweet and that particular claim in the documentation is just obviously false. If you wanted to have a valueless token, use a non-standard interface. If you want to have a value for your token, but claim that you don't necessarily want one, but are interested in the second order effects of that happening, particularly at a governance level, then you would do exactly what Andre did. Which is, as I say, it was a very, very intelligent move. He's covered his ass in natural language and written the executable language to actually ensure that there is a value associated with it. So, I'm not sure if that answers the second part of your question, which is a little bit more difficult to get into, because it's all these second-order cybernetic feedback effects, which could have any kind of unexpected consequence. And what I'm really saying in the whole kernel course, for instance, is that when you're thinking about second-order cybernetics, having tokens that have a specific function within a community, but then also economic value outside of that community, is a second-order cybernetic effect. You really the thing is to be humble, right? Because we cannot actually model what those effects are exactly, because they are by definition chaotic. And this is not to mean chaotic. It means that for very small changes in the inputs, you get very, very large changes in the outputs. It's a very well-defined mathematical concept. It's not really possible, I think, for anybody to come up and say, I know exactly what the second order effects of having a token that both has governance aspects to it and economic value outside of the realm which it governs. It's chaotic. It's chaotic to do that, and not chaotic in a pejorative sense, right? Chaotic in a mathematical sense.
Absolutely. So, I suppose that's kind of comes with the decentralization. The correct term used was second-order cybernetic side effects. Okay. Andy, thanks so much. We are approaching an hour. It's been really interesting to kind of unpack the depth underneath dApps or dApps. Super fascinating for me, at least, because I've seen it a few times, and it really is quite simple on the surface, but got this kind of interesting complex maths in the background. Thanks so much for your time, and I think we'll end it there.
Cheers, everyone.
Thanks, Andy.
Thank you for having me.
Thanks, everyone.
Thank you. Cheers.